Thank you, everyone. I'm James, like you said. I work at Sentry. This is vetting your pager. So what is Sentry, really quickly? It's a crash reporting tool. You know, your app throws an error. Obviously, you all write perfect code, but you know, some of your coworkers don't. They write imperfect code. That happens out in the nebulous, whether that is the internet, whether it's your servers, and instead of serving through logs, they go to Sentry. We tell you what they do. Sentry is actually open source. I'm part of Sentry.io. We run it because operationally, it is easier to pay us to run it than it is for you to run yourselves. What does this talk about? We're actually going to talk about application level metrics and alerts. I'm not going to talk about whether or not you should be paged when HA proxy's down. I'm not going to talk about whether or not you should be woken up at 3 a.m. I'm going to talk about the metrics that actually come out of your physical application. Really quickly, source maps are a thing in JavaScript. When we take JavaScript and we bundle it up and ship it up on the web, it looks really, really small because we don't want to ship around megs, we want to ship around kilobytes. So we do this thing called minifying. And source maps are a way to kind of undo that. It is a map to your literal source. This is how we define it in our docs. But it kind of looks like this when you go to debug without all the help stuff. This is a great screenshot that somebody else took. So it kind of looks pretty garbled. The problem is that they're really expensive to process and actually pull out that source from that map. Essentially, one of our core operations is taking that source map that you provide us and applying it to your minified error in order to show you something that's actually useful. The problem is that it's expensive. Our 95th percentile of source map size is 30 megs. You can chain them together. We have to go fetch that if you didn't give it to us. You could give us one source map, but it could have 100 together, so we really don't know what's going to happen. So that kind of gives us the 95th percentile of processing JavaScript events within 7 seconds. And then my next follow-up question is, how did I get that? Where's that number coming from? And this is the first part of our application level metrics, is at the end of my store.py, I have event.time to process. I give it which platform it's on, I ship that out. And I ship that out to a technology called Veneer, which actually came from Stripe, and it's pretty newish. They kind of just called it production ready like 8-ish months ago, and for Stripe, it's pretty nice for them to say. One of the things that it does is it's a drop-in replacement for dog-stats-d. Dog-stats-d is a local, stats-d replacement that you can run. So a few turtles down, it is the best part about it is that when I send aggregate level metrics, like those time to process, it creates those aggregates globally. So instead of me having a 95th percentile on just my host, I can get a 95th percentile everywhere. So in my 95th percentile, it actually ends up like this, like all the way in the end. I look at Datadog, and I have it across 11 hosts, 10 hosts plus that one global. And I get a graph that kind of looks like this. My red line is the average of everything, and this line that is kind of living next to this, I don't know what color that is, but let's call that green. Whatever that green line is, that is JavaScript. We're so popular that JavaScript moves our entire needle up to that 95th percent. So what happens when things go wrong? Let's talk about that. Nobody likes to talk about things that go right. So if I were to find this other graph, which is our average end-to-end processing, JavaScript versus everything else is totally fine. But we get a backlog in trying to process these. So what happens, right? Datadog kind of comes to us and they say, hey, I got 3 things, and this is the meat of my talk right here. So this is Datadog coming to me and saying, hey man, your average end-to-end processing has jumped over this threshold. It's whatever threshold that we set as our internal SLA. It is indicative of a problem happening, right? My ingress is higher than my egress. And on this right, we have another one, which is saying, hey, I know that you have a bunch of queues, but this queue has not zeroed out in the last 30 minutes. That is, again, the same ingress versus egress. If I keep sending 15, trinkets into my queue, but I can only pop off 10 a second, after 30 minutes, I'm not going to hit 0. That's another indicative piece of the problem, but that's not really a cause. The cause is this bottom one, which is, hey, you have a single source map that's taking up, n% of your processing power. One person sent you a source map that's so gnarly that over 50% of your processing power is just trying to get this off the internet and trying to look up a single event. And so one of the things that we can apply as operational engineers that we kind of overlook is taking similarities to human infections. This is a problem. We also have human problems. We have a problem that has a cause. It's a common cold. You know, I have a cold. That is the, I guess, the start of my pain. A symptom, right? Something that is internally viewable is I have a sore throat. No one else really sees that I have a sore throat because no one's really looking into my throat. Thank you for not doing that. But ultimately, that sore throat and that cold will cause a cough. If I apply this analogy back digitally, what I get is that since I have 50% of my processing power going to one person, all these other people that are sharing in my queue, they're not going to get zeroed out. I have my cause causing a symptom. Ultimately, you know, if I pop in to my queue and if I wait that much of a time because somebody else is hogging all my resources, I'm going to have a terrible end-to-end processing time because I can't come out the back. So that's ultimately my sign. So realistically, who should care about which of these three factors? This is not me telling you, you know, don't care about causes, don't care about signs. But us at Sentry, this is one of the things that we really look at. Is, hey, as an operator, I have to worry about these signs and these symptoms. It's my job to make sure that I have a well-greased machine. But realistically, as a developer, you don't really need to be alerted about these signs. I don't need to know that end-to-end processing is taking a small time unless I'm giving someone like a demo. But I should care that, oh, you know, my application can't actually process at this time. My application, you know, can't really go all the way through what it should. And we kind of meet in the middle, right? There's a cause which comes to symptoms, and we kind of both get paged about that. Not necessarily like literally paged, but we both get told about that. If I would apply this analogy back to maybe, let's say, emergency medical, right? Operators would be something like EMTs. They would be seeing, oh, wow, someone's bleeding out on the street. They shouldn't do that. Let me go rush them off to the hospital and let me stop the bleeding. They rush off to the hospital. They have a conversation between these the EMTs and the doctors, who I would call developers, and they say, hey, this guy's bleeding. Here's all my context. Here's what I saw. Here's what I found. Here's what I think is happening. I'm going to pass it off to you. And I hope that, you know, if any of us were operators and we've gone through some of these incident responses, we've gone to developers and say, hey man, or, you know, hey lady, I have this problem, but I don't really know how to fix it. This is what I've done. This is what it's doing. Here's all of my context. So I can draw a pretty staunch similarity between emergency medical and emergency systems. Realistically, back in the beginning, I said, how does Sentry vet a metric? And what we do in order to kind of break it apart into those three things is we go through this checklist. And in this checklist, we start off with what behavior does this metric actually represent? What does this metric, my end-to-end processing times, what does this mean in a single sentence without saying the word computers? It means that by the time that I was given this, and by the time that I processed it, n seconds, n minutes, n hours have occurred. A follow-up question, what upstream change can affect that behavior? So obviously nothing that we do when we build these systems, especially when they live on the internet, are completely isolated. There's always some problem that happens that's not your fault. Everyone's seen that. Another thing is, what can it affect downstream? What does this end-to-end processing affect? Realistically, this is not going to affect anything. Maybe one of these other things, this cause, this source map snafu, that's the one that's going to be causing another downstream behavior. But this end-to-end processing, it doesn't really matter for anyone else except for users because that is end-to-end. There's no end after the end. And what does it mean for a metric to change? So realistically, whenever we pull up our dashboards, whenever we take a look at, you know, Graphite, Vibrato, anything, you start kind of scrolling and you look for a number that, or you know, you look for a line that kind of comes along and then it goes up, or it comes along and it goes down. Nobody's saying, oh, well, you know, we went from 3 to 5, so that's pretty bad. Nobody actually takes a look at absolutes, you know, that I've seen. I'm sure a lot of people love absolutes, but what we're looking for is change. So what does it mean for that metric to change? What does it mean for end-to-end processing to change? Oh, that means that it was fast, now it's slow. Super simple. How does change differ from average to 95th percentile on the aggregate? So what happens if, you know, if I were to, I guess theoretically, go back to that 95th percentile slide. What does it mean if my average is completely the same, but my 95th is blowing up? If I logically stated that again, oh, my end-to-end processing times, that 95th is blowing up, but that average is the same, that means that maybe a platform is going wrong. Maybe there's somebody who is going so hard that realistically they're going to move that needle, but they're not going to move my needle. And what changes differ when it's isolated versus when it's aggregate? So back when I talked about Veneer, I talked about how we can collect global aggregates. Sentry still collects regular aggregates on per host. A really easy way to say, oh, if this is isolated to a single host, it's probably that single host. If I would apply the same end-to-end processing times, that would be something along the lines of, oh, maybe this host's networking is terrible. It can't connect to any of its local host services. It can't do anything outside of its unit of work, but that's not going to affect everyone else. That's just going to affect my single isolated service. So what solution can we apply to revert the change? End-to-end processing, that's kind of hard. I think a really easy one that we can apply to maybe, let's say the causality of this is if a single customer, a single user is taking up 50% of my processing power, I can just throw more processing power at it. That's something that I can maybe change to move that needle. What happens when we reach a threshold? That was back at the alerts. So when you go out and you define these thresholds as an operations engineer, as a developer, as anyone who cares about your system, those are heuristic, essentially, limits. When you say, all right, I only care once this breaches an hour or 5 minutes or anything that's meaningful to you, which is indicative of an actual problem. Will dependent metrics experience any pain? So when I go to the queue, right, when I have this queue backing up, what other metrics are going to blow up? What else am I going to get paged for if I have that all paging me? End-to-end processing times, the exact same thing that would go and page me. And then the last one, which I believe is the most important question that we ask ourselves when we're trying to page each other, is will users experience any of this pain? Realistically, if you have a queue in your system that's going through deletes, it's really expensive to write deletes because we all want to keep everyone's data, but this might back up from time to time. Is anyone really going to experience that? No. Until maybe you have an SLA that says, oh, we delete this in between this time, but that is a symptom. That's never going to reach outside. So all of these questions, I guess we at Sentry, we ask ourselves ultimately to say, do I want to get woken up at 3 a.m. for this? When I say to myself, will users experience any pain? I might experience a little bit of pain when I get woken up at 3 a.m., but people are going to expect that we do the right thing with our services. So if there's anything to take away, it's how does Sentry know when to page ops? When do I get woken up at 3 a.m. for a problem? It's only for these signs. All of these signs that happen within our infrastructure, they ultimately will lead to anyone being able to notice a difference. That is anything in between, hey, so I sent an event and it's not getting processed, or hey, so I'm loading this page and it's slow. Anything that realistically someone's going to reach out to support, they're going to hit us on Twitter, they're going to complain to their coworkers, and they're not actually going to tell you there's a problem. Realistically, this is the only thing that matters in my sense, because in the background, right, there could be fires, there could be flames, there could be people running around with their hands up, but if everything looks fine, then I think we can give our coworkers the chance to kind of sleep through the night and to tackle that during the morning, during the daytime. I love talking about all of these. I'd love to go all the way back to slides. I'd really love to open up for any sort of QA. One of the things that I hate/love/do find cool is that when we switched from we had regular statsd sending every 30 seconds to Datadog, we switched to Veneer, which since we send so much to a global instance, we say, hey, flush every second, so that instead of building up a giant 30-second chunk and then going, hey, Datadog catch, like we send smaller increments. What we noticed is that things just started completely ballooning. The metric paths that we set up we had told Datadog, hey, this is going to come in every 30 seconds, be ready for it. So when we send them a metric every 1 second, every once, pow, 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 then it's going to look wrong, because what they're doing is they're applying that 30-minute sketch, not 30-minute, they're applying that 30-second like offset to it, and they're multiplying it. They're saying, oh, hey, I got 5 that happened in the last 30 seconds. So immediately when I switched everything over and we're like, okay, we're ready to go, then our like requests per second just like, nobody uses you anymore. And they completely dropped off. So I say a lesson learned from that was that whenever you're switching your metrics backends, use different metrics paths first. Prefix it with veneer. That was I'll say one of the things that I found really cool that I kind of like scratched my head and went, crap, why did I do that? If we have 3 servers that are running our application, there is a 4th server that sits off in the nebulous. Those 3 servers, after computing their histograms, will go and say, all right, I've computed my histograms. I'm then going to send those off to Datadog and send those to this last global server that is then taking those histograms and kind of mashing them all together. And they actually have a little disclaimer that says, oh, well, you'll still get host level ones. So, the HA story is, not yet trademark, but I'm sure they'll figure something out. They're smart people. All right, thank you. Yeah.